All right, let's do examples 3 and 4. All right, this time x squared plus y squared equals 25. This is actually a circle that has its center at the origin and has a radius of 5. And then this is a parabola. So we're going to solve the system and then sketch the graph and show the points of intersection. So in this case, I'm actually going to set both of these because I have an x squared here and an x squared here. I'm going to solve them both for x squared. So I get x squared equals 25 minus y squared. And x squared equals 19 minus y. And because x squared is equal to this and it's equal to that, that means these two things are equal to each other. So I'm going to set those equal to each other. So I get 25 minus y squared equals 19 minus y. We now have one equation with one unknown. This is a quadratic. So I'm going to get everything over on this side so I have a positive y squared. So 0 equals y squared minus y. If I subtract 25, I get minus 6. Since this is a quadratic, I can try to use my tic-tac-toe method. A is 1, B is negative 1, and A times C is negative 6. So I want two numbers that multiply to be negative 6 and add to be negative 1. It's negative 3 and 2. The greatest common factor between 1 and negative 3 is 1. Between 1 and 2 is 1. 1 times negative 3 is negative 3, and 1 times 2 is 2. So if we look at the diagonals once again, I get y plus 2 and y minus 3. If I set each of these equal to 0 and solve, I get y equals negative 2 and y equals 3. So those are my two y values. Now I need to figure out what the x values are. So when y equals negative 2, that's the one I'm going to start with. For the first equation, x squared is 25 minus whatever y squared is, and in this case, y squared is negative 2. Actually, y is negative 2. If I square that, I get 4, and 25 minus 4 is 21. And then x is the square root of that, but let's not forget it could be either positive or negative. So we get the positive or negative square root of 21. If I plug it into the other equation, I get x squared is 19 minus negative 2. Well, 19 minus minus is plus, so this is 21. So x squared is 21, so x is either positive or negative square root of 21. So I got the same answers. This is a good thing. All right, let's try when y is 3. So when y is 3, first one, x squared is 25 minus 3 squared. 3 squared is 9, so 25 minus 9 is 16. X squared is 16, so x is either positive or negative 4. And if I put it into the other equation, I get x squared is 19 minus 3. 19 minus 3 is 16. And once again, I get x is positive or negative 4. All right, so our two, actually in this case 4, because we have a positive and negative. The first one is a positive square root of 21, comma negative 2. That's one of our points of intersection. The next one is negative square root of 21 and negative 2. The next one for this is at positive 4, 3, and at negative 4, 3. And rather than putting you through the excruciating task of me graphing each of these using this horrible mouse, I am going to use Desmos. All right, so our first equation was x squared plus y squared equals 25. And once again, I said that this was a circle. It has its center at the origin, and its radius is 5. The second equation was x squared. Let me look back. Plus y equals 19. All right, so I'm going to zoom out. And so we have a circle, which is the first one, and a parabola, that's the second one. And remember, our 4 points of intersection were at positive square root of 21, comma negative 2. So positive square root of, so 4.583 is the square root of 21 and negative 2. So there's one of our intersections. The other one was a negative square root of 21, comma negative 2. So those two are these two and the other two. So we looked at this one, we looked at this one. Here's the other 2 points of intersection. One of them is at positive 4, 3, and the other one is at negative 4, 3, which lines up with what we have right here. All right, finally, system number 3. This time we have 3 equations. We have an x, a y, and a z. We're not going to graph this one, thank goodness, because it's in 3 dimensions. So what we're going to do is, this is one system right now. I'm going to solve this one. This only involves x or y and z. So I'm going to solve this one for z. And I'm going to get z is 1 minus 2y. And what I'm going to do is I'm going to replace each of the z's up here with this. So we get 2 new equations. This one is x I need to remember not to press the back button. Okay. X minus y, and z is actually 1 minus 2y. That's equal to 2. If I simplify this, I get x minus 3y plus 1 equals 2. All right, if I do the same thing in here, I'm going to get x times y, and I'm replacing z with this, so 1 minus 2y equals 0. I went from 3 equations and 3 unknowns to 2 equations and 2 unknowns, just x and y. All right, so our second step, I'm going to solve this one for x. Whenever I get, I'm going to plug it into this one for x. So if I solve this one for x, I get x is 3y plus 1, because when I add 3y to both sides, I get 3y, and when I subtract 1, I get 1. All right, so I'm going to replace this x with this. So I'm going to have one equation with one unknown. So this becomes 3y plus 1. That's the x. Y stays y. And then we have 1 minus 2y. So these three things all multiplied together equals 0, which means one of them at least has to be 0. So I'm going to set each of these equal to 0. 3y plus 1 equals 0. Y equals 0. And 1 minus 2y equals 0. And then I'm just going to solve each of these for y. So I get y equals negative 1/3. Y equals 0. And y equals 1/2. All right, so here are the only three y values that we could have. So we're going to use this one and this one to figure out what x and z are. So the first thing we're going to do is we're going to start when x is negative 1/3. I'm going to figure out what x is. Well, x is 3 times negative 1/3 plus 1. 3 times negative 1/3 is negative 1. Negative 1 plus 1 is 0. So x is 0. And z, this is really nice because this z only uses y. So z is 1 minus 2 times negative 1/3. Negative 2 times negative 1/3 is a positive 2/3. 1 plus 2/3 is 5/3. So here's one point. The coordinate is 0, x is 0. Negative 1/3, that's what y is. And then z is 5/3. So this is our first point of intersection for these three equations. The second one, we're going to look at when y equals 0. So x is 3 times 0 plus 1, which is 1. And z is 1 minus 2 times 0. 2 times 0 is 0, so this is also 1. So for this point, x is 1, y is 0, z is 1. Here was one of the points of intersection. Here's another one, and we have a third one. Y equals 1/2. So when y equals 1/2, x is 3 times 1/2 plus 1. 3 times 1/2 is 3 halves. 3 halves plus 1 is 5 halves. And then z is 1 minus 2 times 1/2. 2 times 1/2 is 1, so we get 1 minus 1, this is 0. So for the third one, x was 5 halves, y was 1/2, and z is 0. So in a three-dimensional system, for these three, this is lines, these would be the 3 points of intersection, the x, the y, and the z. That's it.